Hello everyone, salve galera, live do All Language novamente. Okay, I'm listening my voice here. Where I'm hearing my voice? Maybe Telegram? Testing, testing. Okay, it was Telegram. Okay, I will try again to make live streams everywhere. No, it's not there. I think I forgot something open here. Ah, okay. Twitch TV. Okay, I think it's working. So everyone is listening me well. I forgot something in this scene. Here. And just a second. Now, yes. Okay, I hope every place has the correct the correct title. I'm not sure if it is, but I can see everyone chats here. I'm currently streaming Twitch, Facebook, Twitter, Telegram, and YouTube, so you can choose whatever you want to watch. Some people prefer Twitch, some other people prefer YouTube, some other Facebook. You choose whatever you like. I will probably stream all these platforms together. I think most of my public are in Twitch. Let me change my music here. Salve, Bruno Melo, beleza? There will be some delay on the chat, so I will prioritize here Twitch, since most of my public are there anyways. Okay, chat is open. Chat. Okay, let's see if I can spell the word right, so the the speech to text can correctly assign it. So it's chat. Okay, chat. I think I will learn. I will learn how to spell English better if I start reading what the speech to text says. So let me see if everything is closed here before switching. Yeah, texture string. I try to use that. I hope it correctly understands me. So hello everyone, welcome to one more English live stream. And today I'm not sure exactly everything I will do. I was assembling stuff for my 3D printer, so I was playing with this stuff. and I have several other things to build for my 3D printer. I can show my 3D printer how it is. It's a new 3D printer. I have Ender 3, which you can see here. Also, I know that here is also missing the overlays. Just a second. This overlay and this overlay. Okay. So this is my Ender 3. It's not working. I'm not printing anything right now. So, tá sem áudio? Tá sem áudio não, cara. Certeza? Eu tava me ouvindo agora há pouco. Let me check. I think in YouTube is not with audio. What the hell, Haystream? No, there is audio in YouTube as well. The audio volume is okay. That's weird, Ademar. É estranho, Ademar. Devia estar com áudio, cara. Toca do Tux tá falando aí que tá com áudio. Eu abri aqui também tava. So, I bought these magnets here. I wish I could put this in autofocus. These magnets. Because the 3D printer bed level sensor is this. Okay. So this is a micro switch. I mean, it's literally a micro switch. Let me get one here. You all probably saw this once. Okay, here. This is a micro switch. So you hit here, it click, click, click. So I think my noise cancelling won't let pass. But the thing is, I have some magnets here. You see? These two magnets, this and this, is attached to the micro switch. So what happens is this part gets in the printer. Okay. So these two wires here. This is on a printer head. Okay. So this is where the printer head is. And let me find it here. Okay, this one is done. Okay. So this thing goes in the printer frame with this, and the tool just sits here. Okay? So this is on the printer frame in a fixed place. So what the printer does when it wants to bed level, it just gets here and pulls out, measure the bed, then it pulls this again here. Of course, I'm not good as the printer will be. And then go out and let the probe here. So the advantage of that is usually these sensors, they break because of the bad temperature. I mean, if you are printing for like 12 hours or something like that, it's easy to damage any type of probe, like a 3D touch or inductive sensor or anything. So this way, this sensor, which is just a simple button, will only be at that bed, the heated bed, when it's necessary. When it's not, it's out of the way. So I was putting the magnets here and making everything actually work, and so far it's working. So we will see when I put on the printer, because I have no idea if this printer will work. Today also some other stuff arrived. Some packages for making Jst Connectors. We need a lot of them. For those who are not used to the connector nomenclature, Jst is this connector. Let me get one here. This is Jst, okay? So let me put a bit more close. This is a Jst connector. So probably most of you already saw this connector somewhere. Okay, but Jst connectors are like a generic name. I bought a kit so I can make these connectors in my own cables because stepper motors use that and a lot of stuff use that. So I will need like make these cables because the printer path, the printer cable path is very long. So I will need to make custom cables. I also bought some silicone wires. So it's like a normal wire, a wire like this. But this place here, this coat, instead of PVC, it's silicone. The difference is this wire is very soft. You see? It stands for a lot of heat, so it can take like 300 degrees Celsius just fine. And it doesn't break easily as the PVC. The PVC is more rigid, so if you have something that keeps moving, it will eventually break. The silicone wires resist more, so I will need to make everything silicone wires. Let me see. There's some other stuff. I received 3 extruders. This is Bmg Extruders. This is the original one I got from Triangle Labs. So basically, this is a extruder. Okay. So here you put the stepper motor, here the filament gets in and the filament gets out. For example, this filament. And then if it's not assembled, it's hard to put the filament here. This is easier when it's assembled. So okay, so this is the filament. The filament goes here, and then the stepper motor can just pull the wire inside. Let me try to fix that. I think this filament is messed up. Okay. So you can see that the gear is turning. Okay. It's pretty simple. So I can open here so you can see inside. Okay, some pieces fallen out. So basically you can see this gear. Let me see. You can see that there is a gear inside here. And there is another one outside. They are basically the same. This one is just free to rotate, and the other one is attached to the gear here. And what it happens is when you close, they both get attached together, and they just force the filament to go. So, for example, you have this notch here. Let me see if I can focus. Okay. So the filament goes here. So both gears, both sides has this thing that grips the filament and makes it move. It's a pretty simple design. It just has a reduction here. There is another gear that goes in the stepper motor and reduces to get a bit more strength. And you can either use this as a direct drive or a Bowden setup, which is you can either use this. Let me just close this one. Something is wrong. I think it put backwards. Yeah, I did that. I just put into the wrong order. So this go here, this go here. Okay, close it. So you can either put this in a side and just make a tube coming from here to the hot end, or you can assemble this in the hot end. It doesn't matter where you put. So I usually use direct drive, but some people use this as Bolden setup, which is separate. Another thing is this thing. This is a shiny one. This goes inside the hot end. So this is the separation where the filament melts and the filament where the filament shouldn't melt. So this bottom part here, which is silver, this goes to the hot side. Okay, so filament will start melt inside this silver part, but not with this orange part here. This orange part should be as cold as possible. So you can see that there is like a small gap here. This is the heat break. It's called heat break because heat shouldn't pass for here. And everything that passes should be dissipated away. So this goes inside the hot end. And the hot end is something like this. Okay? So it goes in the place of this thing here. So you see, it has the same thing. Same heat break, same everything. So this, okay, there was a lot of dirt inside here. So this part should be cool. The other part, let me get the full block here, then it will be better to understand. Okay, I think I have a better example for that. My table is a really big mess right now because there's parts for the printer everywhere. Okay. Oh my god. One more cable attached. This is the new printer Hotend, okay? This is the Voron printer Hotend. And here you have the nozzle where the filament goes. If I remove this rubber, you can see the block here. You see the two parts here? The heatsink and the heat block. This thing with the red cable here, let me see if I can here. So this red cable here, this is the heat cartridge. It's where it gets hot. And this whole block here, this entire block, aluminum block here, this gets really hot. So this is where the filament melts. So if you see here, it's a bit hard to see, but the heat break is between this heat sink and this heat block. So why is different? Because I showed you I have one. Pega bem pra caramba, né, Duchenne? Here. So I have one. Okay, so why I have this different one which has an orange part and a gray part? So the thing is, if you can see here, and now I need to focus a bit. You can see like there is a white stuff inside, right? This white stuff is a Teflon tube, PFT. Teflon tube is used inside here because it stands high temperature, and it also has like a high viscosity. So what? This is a Teflon tube, okay? This white tube here. why it is inside? Because Teflon has a high viscosity, so it's hard to show in camera. But if you put the hand and then slips here, it's very slippery because of it looks almost like it has some oil in there, but there is no oil. It's just like how the material it is. So the thing is, that's used basically everywhere in the printer because it reduces the friction there. So here inside, the friction is a bit worse because when this type of filament like ABS, PLA, or any other filament type gets like a bit more hot than like the environment, let's say, it starts to get like sticky, you know. So now it's not really sticky, but when it starts to get like close to the melting point, it gets sticky. And for ABS, that's the sticky point is like 220 degrees something, and the melting point is like 225. So there is no big difference in both. So it's already melted when it gets sticky. But for example, for PLA, this is way more wide. For example, PLA, I think it fuses at, I think it's something like 180 degrees Celsius, but it gets softened in about 60 degrees Celsius, which is like 20 degrees more than the ambient temperature here. And when it gets soft, like 60 degrees or 70 degrees, it gets really sticky. So the thing is, if you have a Teflon tube, you won't have any problem because it won't stick at the Teflon. But if you have like a full metal, like everything it's metallic, for example, this one, okay? If you have everything coated in metal, it will stick to the metal. Okay, PLA will stick. So when the printer is printing, there is a risk that this thing gets clogged by the filament. And this, I mean, it prints fine, but you can see small defects on the printed part because of that. So most printers come with a Teflon tube, like this. This is the pretty common one, like the Ender 3 comes with that. Basically every printer, commercial printer, is a Teflon tube. But why someone would then change to a full metal one? It's because Teflon melts at about 260 degrees Celsius. So if you want to print some filament that has a melting point which is close to that, you can't print it. For example, nylon has about the same melting point as Teflon. So you have this issue. And or other filaments, for example, the PETG, PETG, it's usually at 240, 245 degrees Celsius, which is pretty close to the melting point of the Teflon. So if you get like some bad Teflon or something like that, you can just ruin all your Hotend because of that. So people usually choose for this type of filaments a full metal one, but then you start get issues with PLA, which is one of the most common materials you use for a filament. And why this one? This one has two colors because of a reason. The silver part is titanium, which is not a good heat conductor. I mean, it's a metal, so it basically conducts heat much better than like plastic, but it doesn't conduct as much heat as other metals. And the orange part is copper. Copper conducts really well heat. You know, the best heat sinks you have, it's copper usually. I mean, you can just say Okay, silver and gold is actually a better thermal conductor. Yes, but they are much more expensive. So you wouldn't make like a silver heat sink or something like that. So the idea is if some heat get over the copper part, it will dissipate really fast. I mean, here everything is aluminum. Okay, the heatsink is aluminum. The this inside part is aluminum. Everything is aluminum. So aluminum is a pretty good heat conductor. So it doesn't make much difference when it passes from one side to another one. I mean, this space doesn't happen a lot. So this is why you have like the bimetal heat break, okay, which is this one, okay? So it's just an alloy here. It has like copper, it has titanium, and it's made for one side should stay really cool, so it dissipates a lot of heat, and the other side is don't care, you know. First time I see you speaking English. I like very good English. Thank you, man. I actually will get like eventually. I think the closed captions died. What? Why the closed captions died? I'm not sure what happened. Hello, testing. Okay, that's weird. Okay, for some reason, the text-to-speech just died. Yeah, audio is okay. I'm just not sure why the closed captions is not working anymore. Maybe Google banned me because I'm using Google for that. Hello, testing. Yeah, maybe. Hello, testing. Yeah, it's stopped everything. Hello, 1, 2, 3, testing. Okay, 1, 2, 3, testing. I think we got back. Yeah, this text transcription is really good. I really like it. I need to check the source code because it's a OBS plugin, and for some reason this OBS plugin uses Google, and I'm not sure how it uses it because I haven't used any API key for that. Não falo em português. Então, só para deixar claro para quem é brasileiro, tipo, para quem fala português, se vocês precisarem perguntar em português, pode perguntar, tá? E eu respondo em português, não tem problema, se vocês não entenderem algo que eu falei. So I was just talking Portuguese that for Brazilian people, they can ask in Portuguese. I will answer in Portuguese and in English, so everyone understands everything. Salve, Riargos. Yeah, I'm not sure why it stopped to work. I just like turn off and on again, and yeah, the API doesn't work in in Portuguese. Usually the Portuguese speech to text is horrible. I mean, it's probably better that I speak in English, get this speech to text, and then uses Google Translate over the English text. That this should be better than just reading my Portuguese, my Portuguese speaking. Because usually the speech to text in Portuguese is really horrible. I mean, Google has a pretty decent one, but still, the Open English tá onde? E aí, Golina? So everyone wants to see how it's going, my new printer. It's getting heavier now. I almost can't like grab it. Let me get it here. Okay, so this is the printer. Let me adjust the focus. Okay, so here is the printer. So you can see that's really big. Pois é, cara, 14 anos, mano. So that printer has like 35 by 35 by 25 centimeters printing area. So here is where the print head goes. Okay, and these 3 axes, I mean, I cannot even show in the let me. So you have this axis, these 3 axes, they are used for the bed. So the bed goes up and down, and the printer head is fixed, just go X and Y. So let me put it back there. It's not only big, but it's also heavy. Let me show you the... Oh my god, in Uruguay. Watch on YouTube and typing on Twitch. So let me show you the printing bed. So this is all the screws I bought. This is for the printer. This is the heating mantle. Let me readjust the focus. This is the heating mantle. So you can see it's 120 volts, 600 watts. So it's a pretty big heater as well. And this is the aluminum bed. So this is where it prints the parts. So this is made with a special aluminum with special requirements because, I mean, the bed gets like 120 degrees Celsius. So it's pretty hot. And the thing is, you cannot use like any aluminum because if the aluminum has like defects inside, which plain forged aluminum has, when it gets hot, it will deform like uneven. So you need like a almost perfect extrusion of aluminum. Not extrusion of aluminum. It's forged, but it's made a bit different. You cannot have bubbles or anything like that. So usually how this is made, instead like you have like, for example, a mold that you want to put like the molten aluminum. You just put from below and not from top, because then you make bubbles not appear. You cannot trap bubbles inside the aluminum. And then when you are like making the cuts and everything, you need to keep the aluminum very cold to not generate stress. No, it's not 6061. I think it's 50 something. I can't remember right now. I can check that. How much this weighed? About 3 kilograms. That bed's not so comfortable. I agree. I agree. Totally agree. I wouldn't sleep there. I think it's 5083. I'm not sure. I mean, it's not a expensive aluminum. It's a common aluminum for machine parts. You know, if you have like a CNC bed, it's the same material. It's aluminum with the thermal stability, thermal dilation stability. It's not. I mean, it's not like a big deal. It's just that you need to choose like a specific aluminum for that. Aluminum that when it gets hot, it expands like in a uniform way and not bend or anything. Because you mean usually you print with a layer height resolution about 0.2 millimeters. So if the aluminum gets hot and distorts significantly for that, your print adhesion will be horrible, you know. So that's why you want like a perfectly flat bed and a very good aluminum for that. It's funny because you usually think like, okay, I will use a glass bed because glass it's very even. I mean, if you look at the microscopic level, it's very even because of how it formed. But glass has a lot of internal stresses. So when it gets hot, it gets uneven deformations. You know, so it gets really warped around. Metals usually don't warp a lot, okay, because metals usually doesn't have like a lot of internal stress, so it's usually not a problem. But you usually want to make like sure that you have the best bed as possible because it's the heat bed. So and well, this is the new Hotend. I think it's really beautiful. This one is really beautiful. There is a lot of stuff to assemble. So it uses like a similar extruder. It was Brazil. It wasn't Brazil. I bought. It was an GGD Metals. It's a manufacturer of metal stuff. It was like I think 700 reais. It's really expensive. But I mean, it's 3 kilograms of aluminum, so it's a big piece. In China, in AliExpress, there is the bed, the entire bed like ready to use. But the thing is, the bed is almost the same price. It's I think in AliExpress costs like 500 reais or 480, but you get like 390 reais of shipping because it's 3 kilograms, so it's really heavy to ship from China. And here in São Paulo, the shipping is almost free. A BOLV printer? No, I haven't saw it. Let me check. Let's switch here. So this is the one you assembled? Well, it's pretty similar. It's an Core XY as well. It's pretty similar from the one I'm building. But I think your bed is fixed, right? Oh, there's several BLVs. Which one you is this MGN cube here? Looks nice. The one I'm building is the Voron Trident, which is this one. So you can see there is three axes for the three axes for the bed. So it's a Core XY, same thing, but the bed mechanism is really different. So for example, I always like to show this Trident bed level. It's really amazing to see this. So you can see the bed is totally tilted. It just measured 3 points. And then it adjusts the bed. That's amazing. So this is pretty similar actually. I mean, just the bed is maybe is different. And the electronical parts is in the back. The one I'm building, the electronic parts are in the bottom. But this Core XY has a lot of nice things, nice features. Like it's really fast. I will use Clipper. I use Clipper because the Voron design has all the optimized stuff for Clipper as well. Everyone uses Clipper there, so it's better to use it. I mean, you probably can use anything, but 500 millimeters per second. That's insane, man. That's like 10 times what the usual speed of the Ender 3. Also, the board I will use, it's Octopus, which is this one. It has a nice case. This board is huge. I mean, look at that. Well, yeah, the Vorons are all direct drive, so it doesn't make much difference. So this board is amazing. It's funny because the board is amazing, but I will not use like any power of the board because the Clipper used all the processing Clipper needs is like in the Raspberry Pi. It's not in the board, so the board is just I/O. So it's funny. And I also bought a screen kit, which is this one. This is a 5-inch screen. So it has like here you can like screw the Raspberry Pi, and look, it's not like it uses the DSI port and not the parallel header. So when you put the Raspberry Pi here, it's the same as putting a LCD screen and HDMI. It was a kit, like you bought you buy the Octopus board and then you just get the LCD screen. Yeah, I think it's 9 driver slots. It's 8 or 9. I think it's 8. It's 8. It has 8 motor supports. It supports 4 extruders. A lot of fans. And this board has a nice thing, a nice feature. The Octopus has like a nice feature, which is you can use. Let me find here. I will need to open AliExpress. I just want. Okay, let's open GitHub. Whatever. Oh my god. I just want to check the Octopus. No, it's not that. This one, maybe. Okay, I can use this. Okay, so you see here, this is all fan slots. But the thing is, you can choose the fan voltage. You can have 5-volt fans, 12-volt fans, or 24-volt fans. You can just choose by jumpers here. So you can actually have like a 24-volt Hotend fan and has like a, I don't know, maybe a part cooling fan that's 12 volts or maybe 5, you know? Ah, okay. Let me change here. Yeah, I think it's a Cortex M4. It's an STM32. I'm not sure it's M4. I think it's M0. Vai lá, toca do Tux. So this is all fan slots from J56 to J50. And you can choose the fan voltage from 5, 12, or 12 to, or 24 volts. So this is amazing because you can just choose any fan you want. You mean? Like, for example, a lot of people like to put Noctua fans on 3D printers. And Noctua doesn't make 24 volts fans. Actually, now it makes, but I mean, it's not pretty common. The most common one are 5 volts or 12 volts. So you can still have like a 24-volt fan for the hot end or the part cooling, which needs to be a really strong fan. But you can like put for the case fan like a 12 volts or 5 volts there. And it has also a CAN port, which is nice. I'm not gonna use for this first Voron. Maybe the next Voron I assemble, I will use cam devices. I'm not sure yet. It has a lot of stuff. I mean, it's 7 motors and it has a lot of configures you can do and whatever. And has 4 heater drivers, which is, I mean, you usually use 2 only. Use like the heated bed and the extruder, but I'm planning. Boa noite, Lucas. I'm planning to do that for the next printer, I think. This one I will probably keep as is, the original product. I mean, because one thing I will surely need to do is after I finish assemble this, I need to print all the parts for the Voron again. Because, I mean, my Ender 3 was not ideal for printing Voron parts. I mean, it works for functional parts, but it's not really pretty, you know? Voron printers has a lot of more... the printer quality is better. I mean, my Ender 3 is not like... It doesn't perform like a Voron. So, I mean, the parts work, but they are not like beautiful. If you check closely, you see defects and everything. So, and after I do that, I might assemble another one. I'm not sure. I mean, it's really expensive, so it will take some time to assemble another one. Oh my god, how I can talk about that? Skleon. Thanks for the follow. Skleon? I'm not sure how to say that. So I was assembling the Gantry, which is this part. And Voron has a nice manual. So I finished assembling this. So you saw. And I still need to put this. This part is here. Okay. I haven't put this. But the next part was to square the gantry. This is pretty easy. But after that, you need to assemble this part here, which is where the hotend goes. And I mean, you need to put like the belts and everything. This printer, Core XY printers are a belt mess. So I just started making this part. So it's this part here. But this part, I mean, you see this thing here? Let me see if I can get a better picture. Here. This is the inductive probe. So Vorons are made for inductive probes. So it has a specific inductive probe that just fits in the back. And then this is used for bed level. But this inductive probe costs about $70. So it's about 400 reais or 500 reais or even more. And there is another issue here. Inductive probes doesn't measure plastic. It just measure metal. So when you are leveling the bed, it will measure the aluminum in the bottom of the bed. So it will measure the aluminum and not the foil, the plastic foil that's over it. So I mean, you have like a magnetic sheet and you have like probably a pay or a glass bed. The inductive probe cannot see that. So you need always to compensate for that. And there is another issue with that, is that inductive probes are very sensitive to temperature. So the Vorons are closed printers, so it's easy to print ASA or ABS or any type of filament that requires a enclosed printer. And the inside temperature gets like 100 degrees. It can get up to, I mean, usually print like 60 or 70 or 80 degrees, but it's really hot. And the issue is inductive probes are sensitive to temperature changes and it measures differently according to the temperature. So when you get the chamber heated, it will measure completely different if the chamber is not heated. So it's expensive, it has its defects. And some people use like 3D Touch or BL Touch and printers. It has the same temperature problems. If you get an enclosed printer, the 3D Touch or BL Touch will not last long. I mean, one of my 3D Touches died like 4 weeks ago when I was printing the Voron parts just because of the temperature. You know, because electronics are very sensitive to temperature changes. And some guy in the internet which was making Voron modifications, I mean, he just thought the basically which was, why not use like a button? I mean, that's the first thing I would think, to find where the bed is, right? Just get the button and then poke the button over the bed. And he did the clicky mod, which is what I was showing in the start of the live stream, which is this. And clicky is a micro switch. It's pretty simple. It's just a button, and it's magnetic coupled. Oh my god, coupled. I don't think the the speech text will get that. But it's magnetic coupled to the printer. So the thing is, I forgot to print the support that goes here, which is this. Now it's printed, but this goes in the back side in place of this thing. So this basically goes, oh my god, here. This basically goes here, you know. Then the clicky probe can be got like this, and then you go to the bed and click, which is why it's called clicky. So I was just assembling that because if you see the manual here, this part is the back side. Here, let me show you. Oh no, it's not the back side. It's the front side. Wait, what? Yeah, it's not the back side, it's the front side. Okay. But I need to put this piece in the back side so I can like screw it together. So with this, we need to have the magnet sheet to apply it. Sadly, it haven't arrived yet, so I will not be able to assemble that. I also need to make the holes in the aluminum bed, which I haven't. I mean, it's not big deal, it's like 4 holes. And I need to apply the thermal pad. And the rest is not like anything hard to do, you know. I got the pick Kevin Mains, thanks for the follow. You know, the rest is pretty simple. I need to make like the bed support and anyways. I'm just thinking about this belt mess. Oh my god. This belt mess will be like a mess. I have no idea how this will be. So let me check. Clicky was supposed to go in a specific direction. I'm not sure which direction is. Okay. So it's on the back side. So it's something like this. It wasn't supposed to be red, but I have more red filament than black filament, so whatever. I just printed red and screw it. Where's the other part here? So it's true M3 by 8mm SHC screws, which I have. Which I have because I expend about 700 reais in screws, so I should have everything. So it's 2 screws. And I wish I have like a camera on my table because it would be easier. I mean, even my now it's better. So let's see. And just put this on the back side. I put the screws before. Since you cannot see what I'm doing, I will just have the screen here. Oh my god, it's really hard to get the screw right. Okay, got one screw. Let's see if I can get the second one. I think I got. I'm just not sure about the height. But looks like it's okay. Okay, so looks like it's done. So this has a cable path. Let me change for camera. So this has a cable path. You see? And then where's the clicky probe? It's here. So then the clicky probe can go here. Then it can sense the bed here. It looks really good. So, okay. So for assembling the... oh my god, this will be crazy. My god. This is crazy. So the belt is clamped against the rail carriage. Okay, it's different from this design it's showing here. Here it's not clamped against the rail. The belt is here. Mine is different. Not sure if it's better or worse. Okay, so now the first thing I will need to do is square the gantry because I didn't done that. This is pretty easy. You just need to like put you let all the screws be like a bit loose. You put everything in one of either side of the bed, the printer. Just force a bit and then screw hard. Let me get the printer again. Oh my god. So I will here readjust the focus because so what we want to square is this thing here. So let me see. My god, I think it's a squared. Let me loose the screws a bit. I wish this was on a table, but I don't have a big enough table for that, sadly. Okay, so these screws are actually a bit loose. The gantry is it's squared, I think. I mean, it shouldn't be like out of square, much out of square, but I mean, it's good to confirm. So now I will like tight the screws here. Oh my god, I don't remember for which side I need to tighten this screw. Okay, found it. Okay, this side is pretty tight. I need to find another. Okay, this one. Because there are some other screws here that needs to be tight. So I just need to be careful because this is a hard ABS, but if I screw really tight, I might break everything. So okay, so now just final screws here. Okay, so it looks like it's tight. So let's confirm this. Okay, it's moving freely. I still need to put a bit of oil here. See you later, man. Até mais, Gorino. Vai lá, mano. Yeah, okay. So basically, let's see if I can show it. this is where this goes. Okay. So we have this movement. So okay, our gantry is squared. So, oh my god, this belt system. Oh my god. So the thing about Core XY printer is, like it's written here, let me show you. It's that the 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 tension between the two belts, you have two belts, one for the A motor and one for the B motor. Both motors control X and Y direction. So the thing is, the belts should have like the same tension. So for that, you need to have like more or less the same length for each belt, and it should be the same material. The same material is easy because I just bought like 5 meters of belt, which I think it's enough for this project. I think it uses here like 2 meters, and so this is not an issue. But the issue is getting the same length, same tension. So what it recommends, it's like I just put one belt, measure everything, cut the belt, and then remove the belt, cut another one with the same length, and then put the both belts. It's a way to get a consistent belt. I mean, you have the tensioners, which is these two parts here. Let me show you. Let me just put the printer on the side here. So this thing here, this is a belt tensioner. What it does is, if you turn this screw, this is a small M3 screw. This screw moves this part here, this L part, this U-shaped part here, which is red. I think here is better to see. So if you like turn this screw, this will get like the red part to come more or far away. So this red part has the belt attached to it, so you can like pull or push the belt in each direction. So you can tension there. But you need, I mean, you don't have like a lot of room to adjust that. So you need to get almost right tensions just as you put everything. So they recommend like put like a belt, measure, cut, and cut another one in the same length and put everything. So let's see this video here. I'm not sure if it's about, I think it's a Core XY concept. I mean, it's probably not a video, but okay. So this is how Core XY works. I basically know how is that, but I couldn't explain without a picture because it's weird. So the Core XY is different from a normal printer. The normal printer is called a Cartesian printer because it uses like Cartesian points for navigation. So basically in a Ender 3 or any other printer, you have like you have a motor for the X axis and a motor for the Y axis. And if you just rotate a single motor, you just make one axis move. The Core XY is different. You have two motors as well, but you have A motor and B motor. So if you hold one motor still and run another motor, it will run in the diagonal from one direction. So if you want to move like along the X axis, you need to like turn both motors in the same direction. So it basically, I mean, this is not a good picture for that. I mean, So you have two belts, you see. You have the A motor and the B motor. And the advantage of this system is that the both A and B motors are fixed. So if you have like a Cartesian printer, you probably either have the X motor inside over the Y axis, or you have the inverse, like the X motor in the Y axis, or maybe you have the X motor in the Z axis. I mean, in a Cartesian printer, we will like have one motor that needs to move another motor. You know, it's no, and the Ender 3, for example. Ender 3, you have like the Z axis that moves the whole thing up and down, and the X motor is on the Z axis. So the Z axis motor needs to not only move the Hotend, but it also needs to move the weight of the X axis motor. So in the Core XY, both motors are fixed. So neither of them need to move each other. So basically here I have a fixed plane for the printing part. My bed moves freely in the Z-axis. So instead of moving everything in the Z-axis, I move the bed in the Z-axis. And then I have the X and Y, or the A and B motors fixed in the frame. So the thing is, the motors only need to have strength to move the head over it. What's the advantage of that? Is that the head is really light. I mean, a motor weighs like 400 grams, you know? So it's 400 grams less weight in the head. And if you have like a lighter head, you can move it faster because you will have less inertia. So that's why it's better. That's why Core XY printers can print like in amazing fast speeds. Okay. But the thing is, Core XY, it's not very simple to understand. You can see here the one belt is here and the other belt is here. It's like a bit of a mess of belts, but the result is good. Okay. So the thing is, you have two belts. You can see that they cross in some places. In the Voron, they don't cross. And that's because they are in different planes. Okay, so one belt gets a bit higher than the other one. So it's basically easier to pass. So you can see here there's two belts. I cannot zoom anymore. Oh, I can't zoom anymore. Oh my god, why I cannot zoom more? Okay, so you can see there are two belts and they are in different levels here. So I think they don't cross. I hope. Because then it will be more complicated. Yeah, they don't cross. You can see here. But I think both of them go to the tensioner. That's correct. Yeah, I think both of them go to the tensioner. No, it's not. Okay, one tensioner does one and the other one does another. But now I'm thinking, I think my tensioners are not in the same height. No, it's not. I thought they was in the same height because they are the same piece. You just print twice. There's no left and right for this piece. But now that I see, it's not centered. It's like one it's above the aluminum profile, another one it's below, so it gets on the right position. So okay, this is good. So oh my god, man, look this mess. I mean, they really did a very good job. Like, I mean, so you can see everything, you know. But oh my god. I think it might be best if I open a CAD file. It's not QuickCAD, it's FreeCAD. I have the CAD file for that, so I can see the belt. I can zoom in and stuff like that. It will take some time to load. It's a completely CAD model for the Voron Trident, so. Oh my god, I already got sleepy. Okay, so you see this is a CAD model. I hid some stuff. So here's one belt. And the other one is hidden as well, so let's see. No, it's not this one, it's this one. So I have this idler, you see here. So see how it works. So this part is where the, let me see if I can remove the case. This is one? No, this is one. Okay. So you see this red part? This red part has this thing inside. So it just holds the belt. It doesn't, it's like a roller here, so it doesn't make any functional part for the roller. But the thing is, it's attached to this red thing. Okay. And this red thing has like a screw here that when you rotate, it moves in this direction. So it tensions the belt. So you can just like get a screwdriver and adjust the tension. This is pretty clever. I mean, it's way easier to install the stuff. Oh my god! I mean, where is Chihuahua? Oh my god! This sometimes this speech to text gets really bizarre. So look at that! Oh my god! And then both belts get here. Let me. This is the x-axis. Okay. So basically, okay, it tells me to end. This is one thing I was thinking about. Where is the end of the belt? So it looks like it's here. You see? I'm not sure if it's a good place to that, but I can't see another place. After I put the, let's see, I don't want to see, I want to see this. Because I still need to put oil inside this. So the CAD model doesn't have, but all my carrier, I think, I'm not sure the name of this. Okay, this thing, MGN12H. It has a hole on both sides that I can put oil, and this oil goes to has a reservoir inside that like lets it the oil goes very slow to the spheres from the roller, and especially this one, which is 12 millimeters, it's a bit stiff to move, so I think it should be like more flexible. E aí, Doug Cunha? Só de boa? Oh my god. So remember I said the motors were fixed? So let's see this. This is one of the motors. This is another one. I mean, it's hidden, but it's there. Let me show. This is the AB drives. This. I mean, we can show everything. Okay. So both motors are fixed. Tá indo, cara. Ó, o projeto da impressora tá indo, cara. Eu tô montando ela aqui. Dando trabalho. Agora eu tenho que colocar essa porra dessa correia aqui. So the printer project is really going really good. I just need to put like now this belt, which is crazy because it's 2 belts. Oh my god. And the thing is, I don't remember how long this is, but let us calculate. E aí, Bruno? Hi, Bruno. How are you, man? So this has 50 centimeters, more or less. I think it's 47 millimeter, for 47 centimeters. So it's 47 plus 47 plus 47. So this is 1.5 meters, basically. Then more 47, I think 45, I think. But this is almost 2.5 meters. So I think I will have barely enough. I have 5 meters. I'm good, man. A bit stressed about work, but I'm good. Why are not you good? What happened? Oh my god, that's a lot of belts. I won't have much room for mistake here. I mean, it's less than 2.5 meters because I rounded to 50 centimeters is less than that because 50 centimeters is the outer size of the printer. So, but still, it's not. I don't have much room to mistakes here. It should be probably like 2.3 meters ish for each belt. I have a 5 meter roll. Maybe I have more. Oh, that's bad, man. Yeah, sure you will get like a job. You are a good developer, so just need to be a bit patient. Let me see how much I have for belts. I have one spool here. Which should be 5 meters. I haven't measured, so I don't know. I'm not sure. I think I have two rolls of that. I just don't know where it is. Yeah, don't worry, man. You will get a job soon. I mean, if you want, you can ask in Twitter, and we can like talk to people like Sibelius and everything to make your retweets until you get like a job. It really works. A lot of people got like jobs with programming jobs and that. Because there is always companies hiring, so it's just matter to like make a match between the company and the employee. Okay, so these are the silicone wires. So they look like normal, but they are much softer. Oh, that's good, man. So you'll find it a job. Don't worry. Just need to have some patience. I'm really not sure if I have another one. Yeah, I think I don't have another one. I have Bolden tubes, the Teflon tubes, but I don't have, I think, another. Or do I? That's the moment I think I need to label where I put this stuff. I mean, I just receive it and just throw it somewhere, you know? So if I have another one, it's somewhere. Because it has like, I think I bought this like 3 months ago. So I can't find it. Aí, mano, há um tempo aí. Um, I mean, it's not a big deal if I don't have enough. I will just need to buy. But it's not very expensive. I think this roll costs like 30 reais or something. It's not a big deal. It's just that I wouldn't be able to finish today. But I should have enough. Um, I should have enough if I really understand what's happening here. Oh my god. Can I change the belt colors? I think I can. Oh no, I can't. I can't because this is a composite. Well, I can use this. Let me remove everything that I don't require right now. So these things I need. Front idlers I need. The Z assembly, I don't. So basically it's this. Okay. So I will start with the upper belt. What's the A belt? Yeah, it's the A belt. Hey String congratulated me because of 100 messages. I think I already received more than 100 messages. Maybe not with Restream, but... Okay. So... Oh my god. Oh, my camera died. I mean, it's not my camera. It's the Elgato capture. But anyways... I'm not sure why Elgato keeps crashing. Some people complain about it. It's the USB card. Some people complain a lot of the Elgato cards in Linux, but sadly it's the cheapest card you can get, like with a decent quality. And it's really expensive. I mean, at least for Brazilians. It's like 900 reais or something. So I think it's really expensive. Okay. After I finished removing the tape from the belt, I think it will be a mess here. So now, tapeless. Okay, I'm not sure if I will be able to show you guys the what I'm doing, but I will try to make something like put the printer here. I think I will not be able to talk. I'm maybe talking louder, but it might get like weird. So, well, that's it. Let's check. Okay. Now I'm just wondering. Okay, it shouldn't make a difference where the belt is. Which is odd. Doesn't make sense to me a bit, but... I mean, if this is in the in the back or in the front, it shouldn't make any difference. In my head, this doesn't make sense. But again, it's a Core XY, this is bizarre, so it probably does. So let's see how I can do that. So it's the upper belt. E aí, igreja São Paulinho, beleza, mano? Meu bot acha que você é moderador, mano. Porque veio pra Twitch TV. Okay, let's try. So this will be a mess. I will just put on the floor. Um, okay. So it's the upper belt, so wait. Oh my god. I can't do this way. Da hora, né, Doug? Um, I have no idea what I should do. Mm. I need to do the reverse path. Hmm. There are two screws that isn't tighted. Ah, I think this is screw I shouldn't tie. No. Uh, eu tenho que começar pelo final. I need to start from the end. So... So this should be like this. Then oh my god, this will be hard. O pior é que ela não tá aqui, mano. Ela tá. Ela tá no quarto assistindo TV. Okay, so Okay. My God, it's really hard to pass the belt over the places. Passar reto. It passes through and go directly for the tensioner. Okay, that's interesting. The the gantry is moving, so that's interesting. That's what it should do. God. Okay. So it looks like I did the whole turn. I Oh my god, why this is not getting in the right position? Ah, now it got in the right position. So looks like it's basically in the right position. Let me check just one thing. Okay. So now I can cut the belt. I just hope I don't make any mistake here. So here is tension. Here as well. Here as well. So let's hope I don't make any bad mistakes here. I didn't know that this belt has a steel mesh inside it. So it was really hard to cut with this plier. Okay, let's just see if I made it right. Okay. Looks like I did it right. So let's cut another belt. Remove this one and cut another one. I think I really calculated it wrong because it's smaller than 2 meters, I think. So it's about this size. So it's not much. So actually I did. Or I have more than 5 meters, which it looks like. I think it's 10 meters, not 5 meters, because there's a lot of belt here. Let me just roll it again, so I will show you. So I still have this, which is a lot. I think it's half. Let me see something to not make this turns to be a mess. I don't think I have any tape here. Oh, screw it. I will just store it. Afterwards, I think about that. Okay, so now it's the craze time. Let me check something. Okay. So let's now try to put the belts in the right position. Oh my god, this is so heavy. Não, cara, eu tô montando essa daqui do zero. Não. Essa daqui tem as peças impressas em 3D, mas eu comprei a superfície e tudo mais. That's a Voron Trident printer. Let me get it here. A superfície de alumínio. Motor. Polia. Né, as roldanas, no caso. Trilho. Essas coisas do tipo. O resto você imprime. As coisas que junto. E placa de controle, essas coisas do tipo. Né? Okay, so let's see if I can put this belt again. Mas está fazendo em software de modelagem ou software de CAD? Que esses tipos de coisas geralmente são melhores em software de CAD. No Fusion, boa, software de CAD então. I have the CAD model for this 3D printer open here. Look. Aí eu uso FreeCAD para essas coisas. I use the FreeCAD instead, Fusion 360. Ah, sim. É, editar STL, cara, aí é bem ruim mesmo de fazer em software de CAD. Vê se você não acha um arquivo .step em vez do STL. Se você pegar um .step vai ser muito melhor do que o STL para você editar. So try to find a step file instead, um, STL file. It will be much easier to modify it. Dot step. It's a universal CAD format. This one is a step file. So, for example, here I have the printer frame and everything. This is a single step file that has everything. So this is a CAD model. This is not a 3D mesh. So it has parts and things like that. So there is a website called GrabCAD that usually have. Tem um site chamado GrabCAD que geralmente tem essas coisas. É onde eu procuro geralmente. Tipo, você consegue achar o modelo do Raspberry Pi, da câmera do Raspberry Pi, coisa do tipo. So you can find like models like the Raspberry Pi, the camera of a Raspberry Pi. Maybe your mouse is also there. É. GrabCAD. GARABCAD. Imaginei. I imagine. So if you import the step file, you will see the difference. I mean, GrabCAD sometimes even has the Fusion 360 files. Okay, so the first belt is in place. So just put this part so I can hold it. So now the second belt. Which is the lower one. The good thing about GrabCAD is because you have all the parts and it's easy. Because if you want you want to make like a part that goes over your mouse, for example, you can just like make a cube and subtract the step file. Então, tipo, se você tiver uma peça, você quer fazer uma peça que encaixa em cima do seu mouse e você pode colocar um cubo e subtrair o mouse, por exemplo. Com STL isso também funciona, mas é meio quebrado, tá ligado? Agora com um CAD file aí sai ó perfeitinho. Okay, I cannot do it reverse. No worries. Isso aí, mano. Boa sorte. Mas o que que tá rolando? Você tá com uma Ender também, né? Uma Ender 3. Bom, o que que tá rolando na impressão de problema? Depois manda uma foto, mano, pra ver. Talvez eu possa ter alguma dica pra te dar. É, manda uma foto depois, sei lá, no Discord, em algum lugar, porque assim é meio difícil de saber o que que é que pode ser o problema, entendeu? Vendo uma peça impressa, aí talvez fique um pouco mais fácil de te ajudar. Cara, não faça isso. De verdade, não faça isso. Vai ficar muito pior pra você imprimir. E você mudar pro bico ponto .2, cara, você vai, tipo, multiplicar por 8 o tempo de impressão. Ele ajuda na qualidade, cara, mas não é. Pelo que você tá falando, cara, tipo, de tá ruim, que você precisa lixar e tudo mais, isso não é problema do tamanho do bico, não, tá? Manda uma foto qualquer depois, ó. De qualquer impressão sua que você achou que ficou zoada, aí eu vejo o que, que pode ser. Como eu já brinquei bastante com a Ender, tipo, provavelmente numa foto eu identifico o que pode ser. Eu não tô dizendo que o bico de 0.2 não fica melhor, tá? A questão é que, tipo... Cara, a qualidade do 0.4 é bem alta. Então, se você tá tendo problema de lixar e tudo mais, de precisar lixar, provavelmente você vai ter esse mesmo problema com 0.2, tá? Porque, tipo, pode ser muita coisa, tá ligado? Pode ser o extrusor que não tá calibrado, então ele tá ou colocando mais filamento ou colocando menos filamento. Menos filamento geralmente deixa a peça com buraco, mais filamento deixa ela com umas bolinhas, ou fica meio irregular a superfície, ou coisa do tipo. Pode ser o X e o Y descalibrado também. Isso geralmente dá diferença no tamanho, tá? Fica com bolinha, tá? Pode ser temperatura ou extrusor descalibrado, tá? Calibrar o extrusor é relativamente fácil. Tem. É... Basicamente, o que que você vai fazer, cara? Você vai esquentar o hotend normal, né? Tipo, vai colocar ele para esquentar. Aí você esquenta ele até a temperatura do seu filamento. Se for PLA, você coloca lá, sei lá, 210, 200 graus. Se for ABS, você vai colocar 230 e pouco, tá? Aí beleza. Tá na temperatura que ele sai. Aí você vai no... Ou pelo menu da Ender ou pelo software no PC. E... PLA tá 200, beleza. Você vai fazer o seguinte, você vai pegar o filamento, você vai fazer uma marca nele, tá? Você pega uma régua ou um... O ideal seria um paquímetro, mas se tiver uma régua já ajuda. Você vai marcar com uma caneta aonde que tá qualquer ponto dele, você vai pegar e olhar, tipo, o filamento tá enfiado lá no extrusor, tá? Marca aquela entrada da extrusora com a caneta e marca 10 centímetros para trás disso, tá? Então você vai ter uma marcação de 10 centímetros no filamento. E aí você faz o quê? Você vai no software, ou pelo menu da Ender, ou pelo PC, e manda ele empurrar 10 centímetros de filamento, 100 milímetros. Tá? Teoricamente, ele deveria parar na segunda marca que você fez, porque você marcou exatamente 10 centímetros para entrar. Se ele não tiver calibrado, ele vai parar, ou ele vai passar para dentro a segunda marca, ou ele vai faltar para entrar. Tá? Se ele passar para dentro, quer dizer que ele está estrudando a mais, então esse é o motivo das bolinhas. Se ele não entrar, se ele faltar para entrar, quer dizer que ele está colocando a menos, então também tem que corrigir. E aí o que você faz? Você faz uma regra de 3, anota esses valores, anota tipo, mede quanto que faltou, tá? Para ele dar os 10 centímetros, e aí eu acho que tem um link de calculadora para você calcular quantos passos por milímetro que você tem que dar de correção. Quer ver? Deixa eu pegar aqui, ó. Deixa eu só colocar isso aqui no chão. É... Eu acho que é esse aqui. Tá? Aí você coloca aqui quantos steps por milímetro tem na sua extrusora, que você pode ver pelo M503. Então, se você digitar M503 lá, você vê, tá? Pelo serial. E aí você olha a linha que ele reportar M92E. Deixa eu te mostrar aqui no meu. Eu tô usando o Octopi, cara. Você pode usar até o Putch se quiser na serial, tá? Então, ó, se eu mandar um M503 aqui... desgraça. Ele pegou várias linhas aqui. Aí se eu olhar o M92 aqui, em algum lugar, ó, tá vendo aqui o M92? Isso daqui é o número de passos por milímetro. No X, no Y, no Z e no extrusor. Então o meu aqui, ó, 425 passos por milímetro no extrusor. Você pega esse valor, você vai colocar aqui na calculadora aqui, quer ver? Ô, caralho. Então, sei lá, o meia linha tá 495, é isso? Ou 425? 425, tá? Então, isso aqui é 425, tá? Aí, beleza. Extrudei 100 milímetros. Aí você vai colocar quanto que extrudou. Então, vamos supor que faltou 1 centímetro. Se faltou 1 centímetro, ele extrudou 90, tá? E aí ele fala aqui qual que é o novo valor que você tem que fazer. Aí você só roda isso daqui, M92 E472, faz o teste de novo e vê se ele extruda certinho. Se isso extrudar certinho, você roda um M500 e ele salva a configuração dentro da impressora. E aí o extrusor está calibrado. Então o extrusor é super fácil de calibrar, tá? Você pode ter que calibrar o XYZ. Isso daqui é o tamanho da peça, tá? Aí o ideal, o que você faz? Imprime um cubo de calibração. Se você procurar Calibration Cube no Google, você vai achar um cubo que tem XYZ nele. Aí você imprime, ele é para ser 2 por 2 por 2 centímetros. Você vai fazer a mesma coisa, cara. Ah, você mediu lá, em vez de 2 centímetros no X, deu 1,9. Beleza, mesma coisa. Tá? Só calcular. É uma regra de 3. E aí você seta os valores da mesma maneira. O ideal é no PC, cara, porque você precisa acessar o terminal aqui. Dá para configurar por ela, mas é melhor você fazer isso pelo ligado no USB, tá? Para você poder digitar os comandos é bem mais rápido. Aí, tendo certeza que seu extrusor está calibrado, aí se continuar as bolinhas e tudo mais, aí pode ter outros problemas. Pode ser questão da temperatura, enfim. PLA tem PLA às vezes que você tem que imprimir a 190, tá? Enfim, tá? Aí tem que fazer esses testes aí. Definitivamente assim, bolinha não é causada por erro no XYZ, tá? Isso não é. Ou é extrusor ou é temperatura, é um dos dois, tá? Erro no XYZ vai ser o tamanho da peça sair errado. Então você fez uma peça de 5 centímetros e saiu 4,8 ou 4,95, tá ligado? Aí beleza, aí você tem que corrigir o XYZ aqui, o steps per milímetro, tá? Mas se o problema é bolinha de você ter que ficar lixando e tudo mais, mas o tamanho tá certo, aí é só extrusora ou temperatura. Pra ser bem sincero, não vem calibrado de fábrica certo, tá? Então é muito provável que esteja errado. Quando tá errado para mais, aí você tem esse efeito da bolinha. Quando tá errado para menos, você às vezes fica com uns buracos na peça. Oh my god, I can't put the belt in the place. I'm not sure why. My camera died again. Let me use my cell phone light. No bico de 0.4, cara, dá pra fazer umas qualidades muito boas. Você vai saber quando você precisar de um bico menor do que 0.4 quando você chegar na resolução mínima da altura da impressão. Tipo, se você pegar, por exemplo, e falar, putz, cara, eu tô imprimindo a 0.1 milímetros ali na altura da camada ali e não tá saindo na qualidade que eu quero. Eu quero que fique mais liso ainda a superfície. Aí beleza, aí você muda o bico. Se não, cara, 0.4, mano, faz umas impressão muito boa. Beleza, qualquer coisa chama lá. Ó, só pra você ter noção, deixa eu pegar uma impressão aqui que eu fiz com 0.4. Ah, aqui ó. Isso aqui, cara, foi com 0.4. E foi na Ender, tá? Então, tipo, dá pra fazer uns negócios bem bons, cara, com 0.4. É que se você diminuir o tamanho do bico, cara, mano, o tempo começa, tipo, a ir pro saco, tá ligado? E assim, toda vez que você diminui pela metade o tamanho do bico, você multiplica por 8 o tempo de impressão. Então, se sua impressão levava 1 hora pra fazer no bico 0.4, ela vai levar 8 no negócio. Então, você já vê como é que isso aí vai pro saco, né? É, então, você foi imprimir uma caixa simples aí 16 horas, cara. Se fosse no 0.2, você ia levar, tipo, 4 dias. Ah, tá, se mudar o bico, entendi. Tanto que eu tô cogitando aqui colocar um bico 0.6, cara. Não, não é a mesa que tem que calibrar. Você tem que nivelar a mesa independente do bico que você tá, cara. Mas não tem que recalibrar nada quando você muda o bico. Geralmente o pessoal recalibra a extrusora porque pode mudar um pouco, tá? Porque tá passando menos coisa e tudo mais, mas não costuma ter que calibrar nada, tá? Você só tem que, no software, no Cura, no Super Slicer, coisa do tipo, você tem que mudar o tamanho do bico, tá? Isso você precisa fazer. Você não pode usar a mesma coisa que você imprimiu. Oh my god, man, I can't put the. Vai lá, mano, boa noite. I can't put the belt in the right place here. It's Murphy Law, it's just because it's the last belt. And the last pass. It's not the last pass, but almost the last. Just a second, let me use the light here. I think I will need some pliers or something like that. Finally. So finally the belts are in place. So let me check which screw I should use here. M38. Okay. Okay, so I'm putting all the screws. So, but they're not tightened because I need to pull the belts here. I think they are pretty. Pretty stiff already. So okay. Uh, Now I need to wait. The belts are in place. Okay. So the belt system is in place. So now I can move this and this position. I'm not sure why it's that hard to move this stuff, but this direction should be I should be missing oil. There are some weird noises here. sem show! Muito obrigado pela raid. Thanks for the raid. É nóis, mano. Pô, GV 2009. Salve, turma da GV 2009, mano. 2009, mano. Bons tempos na GV, velho. É, pois é. Cara, eu tô montando uma impressora 3D do zero, velho. Aqui, ó. Acabei de colocar o sistema de polia dela. E só que eu tô vendo que uma das roldanas tá pegando na polia. Aí eu tô tentando ver como é que eu resolvo isso. Eu acho que foi uma das peças aqui que eu imprimi empenou. Aí ele tá empurrando um pouquinho pra baixo a peça e é o suficiente pra polia fazer barulho. Tá pesado pra cacete isso aqui. Hum, Nossa, cara, o pior que é tudo preto, eu não consigo ver, mano. Everything is black here, so I can't see what's happening. The belt is black. the pulley is black and the belt is black. Oh my god, it's 1 a.m. I just saw this now. Okay, everyone. I will check this tomorrow night. At least the belts are in place now. So, I think that will be for me today. Let me adjust here. I think that will be for me today. It's 1 a.m. here in Brazil. So I should get some sleep because I need to work tomorrow. So let me see, for the Twitch I can make a raid. Let's see who is online. Boa noite, sem show. Deixa eu ver. Libose tá dormindo. Cara, não jogo. Cara, eu tentei jogar de novo. Não. Não, é que eu conheço o Libose. O Libose fez uma raid pra mim por causa do 469. Aí ele contou a história toda lá do mistério do 469 e tudo mais e aí, tipo, aí a gente ficou amigo, tá ligado? Foi um belo de um susto, né? Porque foi 600 e não sei quantas pessoas que caíram na minha live, né? Então, foi um puta de um susto. Sim, ele é... Cara, e por coincidência, tipo, ele mora muito perto de mim, tá ligado? Ele mora, tipo, cara, nem 1,5 km de mim. Eu imprimi em 3D pra ele umas runas do Tibia pra ele poder sortear e tudo mais. Aí eu mandei pra ele, tipo, mano, super perto, tá ligado? Eu gastei, tipo, 5 conto pra mandar pra ele. Eu ia mandar a raid pra ele, cara, mas ele tá dormindo agora. Ah, Ô, mano, pior que tem quase ninguém com raid aqui. Deixa eu ver aqui. Vamos ver o total. Vai lá, mano. Boa noite aí. Pegar e fazer raid crônica. Crônica é uma pessoa aqui que tá com mais ou menos bastante viewer aqui. Tá mais ou menos aqui junto com o Libose aqui na minha lista, então. Não, deixa eu ver alguém melhor pra isso. Ai, ai. Pra quem que eu vou fazer raid, mano? Mano, vai pra ela mesmo, vai. Okay, everyone. See you next time. Let me start the raid. And stop the stream in other places. Então, vejo vocês